Do you know who's logging into your network? By the end of this video, we will be able to describe the user authentication process in SDA. In the last video, we talked about how we can deploy policy against certain users in our environment. Maybe we want to create a policy that says that user A can't talk to user B even though they're in the same subnet. But that raises an interesting question. How do we know who user A is? How do we know who user B is? In this video, we're going to explore exactly how we handle user authentication in a software-defined access environment. We mentioned that when an end device is going to send traffic onto the network, that network needs to be able to tag that traffic with a VNID and an SGT, but the tag is dependent on who this user is. This is why it's important to authenticate the user when they first log onto the network. If we know who the user is, then we can assign the appropriate tags, which means we can enforce the appropriate policy. But this is the important first step. Who are you? Well, we have three main ways of identifying who a person is. The first method is 802.1x. So here's how 802.1x works. We have a supplicant, and that's just another word for the endpoint, which is the network device trying to log into the network. Next, we have the network authenticator device, NAD. In most cases, that's our upstream network switch, the one we're attaching to. When we're trying to log into the network using 802.1x, we're going to authenticate with the network authentication device. And then we have the authentication server itself. Now in an SDA environment, this is going to be ICE. However, ICE can be integrated with Active Directory, for example. So we can tie into your existing directory services. So here's the process. Our device is going to send a login message to the network authentication device. The authenticator is going to send that request via Radius to ICE. Radius is an authentication protocol that a lot of networks already use to authenticate logging into network devices. But now we're extending that to log in the actual endpoints in the network, not just someone trying to access a network switch. If the login attempt is successful, meaning you have the right username and password, then the authentication server is going to send a message back to the authenticator, and that message is called an access accept. That tells the authenticator that that supplicant is allowed to access the network. And because ICE is the one that did the authentication, ICE knows who that is. And we can enforce our SDA policies against that endpoint. Now, a lot of PCs and laptops are capable of doing 802.1x authentication, providing usernames and passwords. But what about a device like a phone or a printer? How are they going to participate in this fabric authentication process? Well, we have another option called MAC Authentication Bypass. In this case, what's going to happen is when we connect this device to the network, the authenticator, the network authentication device, is going to wait for an 802.1x username and password exchange. However, if that doesn't happen after a time, we're going to send a MAC authentication bypass message to authentication server, again, in this case, ICE. Contained within that message is the MAC address of the host trying to log in other words, the MAC address of this phone in this example. And if that MAC address is a known host and we're allowed to log into the network, ICE will send back that access accept message. Now, as you can probably imagine, if this is going to work, ICE needs to have a database of all of the MAC addresses in the environment that are going to log in using this methodology. And unfortunately, this can be a manual process to go around and collect all of the MAC addresses and populate that in ICE. So this is why we desire to use 802.1x everywhere we can, because this method leaves a lot to be desired, but it does make for a good backup option. Now, we do have one other option we need to discuss, and that is web authentication, or WebAuth. WebAuth is a way to bypass the need to deploy 802.1x supplicants on some of these devices, because some PCs can natively handle 802.1x, but in some cases we need to install a supplicant, a piece of software that will perform the 802.1x authentication process for us. And this can be painful to go around installing this everywhere, and so WebAuth can get us around this requirement. What we do for WebAuth is we allow the ability to get a DHCP address, which will contain a DNS entry. Then the next time the PC tries to access a website using the web browser, we're going to intercept that communication and direct them to a website that allows them to log in. So they will provide their username and their password on this website, and that will authenticate them into the network. This is an option that prevents us from having to install the supplicant everywhere. However, anytime a user connects to the network, we need to go through this authentication process, which itself can be painful. So in the end, we have three solutions that will work. All of them are good, none of them are perfect. We simply need to find the right authentication process for the need. And with that, you are now able to describe the user authentication process in SDA. I hope this has been informative for you and I'd like to thank you for viewing.